Okay, so we have to ask Dan now, what did he do with this gravitational lens and what he found? I
Right.
want to
Okay,
know
so
now,
let's
right?
go. Okay, let's go to the discovery. So Dan has found what is probably the most distant galaxy ever seen, and he made it using Hubble and Spitzer. And he found that and of course, he found it using gravitational lenses, which we've talked about quite a bit. So apparently, there's this cluster of galaxies that is directly between us and this most distant one. That because of its orientation to us, it sort of acted as this enormous magnifying glass, which boosted the sensitivity of Hubble and Spitzer. So, Dan, why don't you? So let's talk about this. And if you want, I can put the image of the galaxy up if you'd like. So
Sure,
while
yeah,
you're
if you have
talking,
that.
yeah, let
Yeah,
me.
Yeah,
that'd be
so
great.
this we believe it's the most distant galaxy yet to be discovered. And we've had great press coverage about this. Although one of the articles said, we seem to have these discoveries every couple of months. There's another, most distant galaxy. So what's and almost
Yeah,
like,
what's new,
what's
Dan?
what's
Come
what's
on.
the big deal, right? But that's kind of the point, is that with this new clash survey, we've now found two of these that are very distant. So within the first 500 million years of the universe since the Big Bang, Clash has now found two galaxies. And previously there was only one, and that was in the ultra deep field, which we're now calling the extreme deep field. And so now with Clash, we found two of the three most distant galaxies.
Oh,
And
let me put that up. Keep
right.
talking. Sorry.
Right, and so we're able to do that because we've observed, as of the time I wrote it, we'd observed 17 of these clusters, and and so they magnify the distant universe, and so it's more efficient than looking in these blank patches of sky where it's unlensed. And so the only drawback is that we have this cluster in the way, and it can be a little bit messy, but
Yeah,
you
but
have
without it, you couldn't
great.
see anything. So.
Right, but you have these great magnified images, and so now you're able to have much more light that comes to you from these distant objects, and so now you're able to analyze them in more detail. These little red specks, and so we are pushing the limits of Hubble. So even
Mhm.
magnified, and even with the Hubble telescope, you still see them as these small red dots, basically. And you see in that image, if it comes back up, you see there are these three different images of it as it's being lensed, and they're different brightnesses. So the two of them are pretty bright, well, relatively bright, I guess. The one of them is fainter.
JD1 and
They're all
JD2, right?
right. So there they are. So the two. So yeah, none of them are. I shouldn't say they're bright, but two of them are brighter than the other one, and so yeah. So there's a lot of light coming from them, relatively, compared to if they weren't being lensed, and so that'll enable us to study them in more detail, to some degree with Hubble, and definitely with the James Webb Telescope, the successor to Hubble.
So
Okay.
just to give an idea for whoever is listening. So you see three different images of the same galaxy. How far
Right.
is this galaxy, first of all?
Right. So the light has taken 13.3 billion light years to get to us, and the universe has been expanding that whole time. So it's even more distant than that. And the light, and along the way, it's taken a detour about, I think it's about several billion years into that journey. It took
Hmm.
this slight detour around this galaxy cluster to us, and during that time, the universe has expanded in size by a factor of 12. So the universe has been expanding all along, and so with that expansion, light in the universe has also been stretched. So things like
Mm.
atoms haven't been stretched out. Their sizes are dictated by electrical forces. But light waves
Well,
have
light
been
waves.
stretched out. So this galaxy was emitting light in the ultraviolet due to its hot young stars were burning really brightly. And that ultraviolet light has been stretched into the light waves that we can see, and then later into the infrared, light waves that we can't see, but light waves that the Hubble can see. And so we've measured that the light has been redshifted, we call it.
Hmm.
That that it's so that space has expanded by a factor of 12 in that time, and so it's almost redshifted out of the visible range of Hubble. So Hubble observes in infrared wavelengths. If it had been shifted much more, Hubble wouldn't have even been able to see it. And it's been redshifted by this factor, and we measure redshift in this units of redshift it's one less than this expansion factor. So redshift 0 corresponds to today, when it's the same size as it was. Well, it's a factor of 1.
It's now,
So
right?
so what we find is that the redshift we measure is 11 for this galaxy, and I have let's see, I have an image that shows.
Okay, okay, wait. Before you go away too far, so
Right.
there's a good comment here that's relevant to this. This guy,
Right.
T.S. Joe in Cinema is asking, give us a number. How far away is that galaxy?
Right. So right now. Well, okay. So
and you got to include expansion rate, right? You got to include the universe.
So I just figured this out yesterday, responding to it. So it's about 32 billion light years away right now.
32 billion. And the reason it can be further away than 13.3 billion years, which is the speed of light in this thing, is because the universe has been expanding during that time.
That's right.
Right. That's right.
That's something that I have a hard time getting across to people in a lot of the videos. They just don't seem to understand it. Like once I posted a video about this and stated a number like 47 billion light years or 47 billion light years away, and people just couldn't get it. And it's a hard concept. It really is, because they forget that, hey, wait a minute, the universe didn't just sit around this whole time. It's been doing stuff. It's been getting bigger the whole time.
And when I say it's 32 billion light years away, now imagine we decide we want to go visit this galaxy. We want to see what's going on in this most distant galaxy we've observed yet. So we set out in our rocket ship. Now suppose we manage to build a rocket ship that goes at the speed of light, and we set off for this galaxy. It's not going to take us 32 billion years to get there. It's going to take us even longer than that, because space is continuing to expand. And so I haven't worked out that number, but it'll take even more than 32 billion years. And
That's
so we don't have a rocket ship that goes that fast, and that would be a long time. So it will
take a little longer.
That's right.
So
Mind equals blown, okay?